All right. As you probably know, hopefully that you've seen your email I've sent out about the exam. I've graded all of them. Overall, I thought we did very well. Some of you all, did good on the law of sines, law of cosines, and then you didn't do well on the logarithms and the binary, hexadecimal, octal numbers. Others did well on logarithms, this and that and everything. So, there was really nothing that stuck out to me as a problem. But I just want to kind of go over things for the final, just to make sure you understand, again, what's going on. It's been posted several places, reminders about the final, that it must be proctored. The other issue is that you must pass the final in order to pass the class. So no matter what your average is, it doesn't matter if you've made 100 on every single assignment. If you make a 50 on the final, you fail the class. So you need to understand that, and it never fails. When someone fails the final and then I have to fail them, they email me and wonder why, because, well, my average was 70. Well, it doesn't matter. Okay. That's just the policy. So you must pass the final. To help you prepare to pass this final, I've purposely made that final, the exam 3, due a week and a half, almost 2 weeks before your final exam. This way you can practice, you can study, you can get ready. So to do that, first of all, make your sheet of notes. You get a one page, front and back of notes. It can be anything you want. No one's going to look at it and say, what's on it. It's just whatever you want. So what I would do, I would, make up your formulas, any sample questions, whatever that you want on it that you think will help you, and take the practice final exam using only those notes, because that's all you get on the day of the final. So if you're one of those people that need to look back and mirror the examples for your test, you're not going to do well on the final. So you have got to stop that and take the practice exam as you were if you were taking the final exam. Limit yourself to time, sit down one day and just take it with your notes, your scrap paper, and your calculator, and just see what you can do. And you'll know what you need to work on and what you are good at. So, don't just sit there and say, well, I get to take a sheet of notes and I'm not going to study. That's bad idea. Bad idea. So try to do that. Now, I just wanted to kind of go over a few things. So I'm going to be moving this camera off me, which is probably good for you, to do a few examples. Okay. Just of a couple things that I noticed on exam 3 that I think, you might need a little more practice with, a little more explanation. I thought the videos for the conversions between number systems were very good, so I did not send out an example. A friend of mine who actually teaches in the program made them, so I'm thinking these are good, and they are good. Don't know if everybody watched them or not, or you just didn't practice the skill enough, but some of the answers were really not kind of even close to what we needed. So I wanted to do that, and I also wanted to kind of go over logarithms and exponentials, because keep in mind the final exam covers everything we've done. Okay, so let me move this camera over and let's look at a few things. All right. Okay, so I think we're good. All right. Uh-oh, my makeshift camera holder is not doing well. So let's see what we got here. All right, so logarithm. A logarithm has a base. It has what we call the number, and always on the right side of a logarithmic equation is what we call the exponent. The exponential equation has a base, the exponent is over here, and the number is on the right side of the equal sign. What some of you all were doing is you were either getting the number and the exponent confused, or you just weren't changing from the one form to the other correctly. So when you are solving a logarithmic equation or asked to rewrite it, you've got to change it to the exponential equivalent. So in other words, if I had log base 5 of x is 2, well, the only way I can solve that is I have to get my base and my exponent and make it equal to my number. So I have to change it to this. Your base is 5. Your exponent is 2. So as an exponential equation, I get 5 squared equals x. So x is 25. Okay? Conversely, if I am asked to solve 2 to the x equals 16, well, my unknown is the exponent. So if you look at the setup up here, the exponent's on one side. I can get the other two items on the same side of the equal sign, which allows me to put it into my calculator. So my base is 2. So I go log base 2, my number is 16, it equals x. Then I have to do my change of base formula because my calculator will not do base 2, it's only defaulted to do base 10. Put this into my calculator and I get x equals 4. So you've got to understand how to change from one form to the other. All right. That's logarithms. Now, I've sent out another video with this as well. There's video examples, so you need to work harder and practice more to get this down. I mean, just watching these videos is not enough. You've got to get in there and work the problems. Now, binary. Our number system is called the decimal number system. And in our number system, we have the ones place, the tens place, the hundreds place, the thousands place, 10,000s, 100,000, so on and so forth. Binary is base 2. So that means every place value is a power of 0. A power of 2, excuse me. So we have a 2 to the 0 power, which is a ones place. We have a 2's place, we have a 4's, an 8's, a 16's, a 32, and so on and so forth. So if I have some binary number and I want to convert it back to base 10, which is decimal system, well, I have 132, I have 1/8, 1/2, and 1/1. I don't have any 16's or 4's, so I add this together, and that's 43 base 10. Now, to convert from decimal back to binary, well, you can do the series of divisions, but think about just kind of placing ones and zeros in here till you get what you need. So if I have, let's say, 56 base 10, and I want to know what it is base 2, well, I'm going to do 32, 16, 8, 4, 2, 1. I'm not going to go bigger than 32 because 64 is bigger than 56. So I know I have 132. Well, 56 minus 32 is 24. So that leaves me a 16. 24 minus 16 is 8, and 8, and the rest are zeros. So that would be 111,000. Okay. Base 8, a little more difficult, but it follows the same principle. So octal, we again have place values that are powers of 8. So on and so forth. So you convert the same way. The only difference in octal is your digits can go from 0 to 7. Because in our number system, our digits go from 0 to 9. Once you get above 9, you're going to a different place value. Same thing with base 8. So if I had 1, 2, 4, 7, base 8, to convert that to decimal, I would have 1/512 plus 2 times 64 plus 4 times 8 plus 7 times 1. So that gives me 512 plus 128 plus 32 plus 7. That's 640, 672, 679 base 10. Okay? Now, converting from octal to decimal, or from decimal to octal, is a little different because it's not as easy as binary, because binary is 1 or none. Octal can be 1 to 7. I mean, you can still do trial and error and place these numbers in here, but it's not quite as easy. So what we can do for decimal to octal, we can do a series of divisions. Now, we always divide by the base we are converting to. So if I take 679 divided by 8, and here's where I think we do get confused on. So if I take 679 divided by 8, I get 84.875. Well, I have 84. Now, my remainder can be found one of two ways. You can either take the 0.875 times 8 and get 7, or you can take 84 times 8 and then subtract it from 679. Either way gives you your remainder. Now, I pull down the 84, and 8 goes into 84 10 times with a remainder of 4. Then I take the 10 divided by 8, and it goes once with a remainder of 2. Take the 1 divided by 8, and it goes none with a remainder of 1. That's how I know when to stop. When that last divisor, or my dividend as we call it, is 0, I stop. Now, we always read from the last remainder. This is your first octal or binary or hexadecimal, whatever you're doing, digit. So that gives me 1247 base 8. Okay. So I'm not going to do hexadecimal, which means I probably won't put one of those on the final, but it works the same way, except hexadecimal has A, B, C, D, and E, because we can't do 15s, 14s, 13s, 12s, 11s, and 10s. So we use letters for those. So anyway, practice that. Practice that. Okay. One last thing I want to kind of go over here is where you can find your information. Okay, so I'm going to log in here to the class real quick.